Hello and I want to welcome you to Algebra. Today's topic will be sets of numbers. I'm going to be talking about what type of numbers there are, including natural numbers, whole numbers, integers, rational numbers, irrational numbers, and what real numbers are. Let's start our discussion by talking about natural numbers. Okay, natural numbers are the counting numbers that you started off saying when you first started learning about math and numbers in general. And let's give some examples. The natural numbers include 1, 2, 3, and anything else going in that positive direction. Now we want to talk about whole numbers. I think you'll see in this discussion that the sets of numbers build on each other. The whole numbers include the natural numbers, but they include 0. So they are the entire counting numbers that we just talked about, and 0. So to put that in the example term, let's do our little bracket. Do 0, 1, 2, 3, dot, and then do our brackets to show that it keeps going all forever in the positive direction. Now, let's talk about integers. What is an integer? An integer are the natural numbers, the whole numbers, and then we're going to add to what's on this side of the 0. The integers are going to include the negative values. So, we're going to have positive and negative. Whole numbers and now let's put this in our little example, little brackets. So we're going to include the negative values. Let's sing here all the negative values that are whole numbers, negative and positive. So let's say the dot, start with a -2, -1, 0, and then we'll head into the positives for the natural numbers with 1, 2, and let's do our dot, and then we'll close up with our brackets. Alright, and then let's talk about rational numbers. Rational numbers are written like A over B. Where A can be a number and B will be a number. Decimals that terminate and decimals that repeat. They're square roots of perfect squares. So let's jot that down. Decimals that terminate mean they don't go on forever. Kind of like 1/2 would turn into 0.5. That 0.5 does not keep going, it just stops. decimals that repeat. if you take the fraction 1/3 and you put in your calculator 1 divided by 3, you're going to get a repeating number, a decimal, and then it's going to have the same repeating number. That's a repeating decimal. And the square roots of perfect squares. And perfect squares are numbers that are multiplied by themselves. Like 7 times 7 is 49. So if you had what's going to be the symbol, the square root, 49, you're just going to get 7 out. So let's just do some examples. An example for a over b would be like 3 over 7, where you see 3 and 7 are each natural numbers, but the division bar makes them irrational. You can also say something like a negative 5 over 9, where that fraction is just making it a rational number. And you can also say 8 divided by 1, or 8 over 1. That is still a rational number. For decimals that terminate, look at things like decimal 23, or even 5.34. That decimal does not keep going forever. Okay, decimals that repeat, this right here, are numbers like 0.333, and then we'll put the little bracket on top to show that it keeps repeating. Or you can even do something like this, where you have decimal 1 2 1 2 1 2 ... Well, that shows that the pattern is going to keep going forever. And then the idea of the square root, remember we said that's just two numbers multiplied together, that they're the same numbers under the square root sign. So you can say like square root of 25, remember that would just come out to be 5, because 5 times 5 is 25, and it's under that bracket. You can even say something like the square root of 49, because that's just going to be 7. Okay, now you're probably saying, well, what about decimals that do not repeat, or decimals that do not terminate, or some ugly looking square root things? Well, that's going to fall under the irrational numbers. Irrational numbers are decimals that do not terminate and are not repeating. And they can also include the square roots like this, but they will not be perfect squares. Decimals that do not terminate and are non-repeating. And then we can also say square roots of non-perfect squares. And let's give some examples. Examples of numbers that, or decimals that do not terminate or that are non-repeating would look something like this. Decimal 3 2 5 7 ... And see, we can see that this pattern is not going to continue. You can also say something like 5 decimal 9 2 1 9 ... No pattern is happening. Even something like this. Decimal 1 2 1 1 2 1 1 1 2. we can't really develop a pattern from this, so we're saying it's not terminating and that it's not repeating. And then for this example, square roots of non-perfect squares. Well, just think of two numbers multiplied together. Can a number times itself give you 7? No. So that is a non-perfect square. Even something like the square root of 27. And pi also fits into this category. Pi is an irrational number. Okay, and let's finally conclude this discussion of sets of numbers by just saying what a real number consists of. Real numbers are all of the numbers above. That's right, all the numbers we discussed above are real numbers. That means natural numbers are real numbers, whole numbers are real numbers, integers are real numbers, rational numbers are real numbers, and even irrational numbers are real numbers. This concludes our discussion on sets of numbers.